just take your time and review those. That's going to be important for me. Please do that. Please do that. And shoot me another email. I'm going to try to be as updated as I possibly can, emailing back every individual. I had some of your parents email me. You guys emailed me. So it's kind of going to go back and forth. I think I went all the way back to August 24th to email back. So it just took me a while. I had like 40 emails last night. I was up till like 1 o'clock. So hopefully I got back to you. Hopefully I made the change. Hopefully, if not, just please shoot me a text. No, not text. Don't shoot me a text. Shoot me an email. Don't text me. I won't respond to you. My wife is going to be like, who's texting you? Student? No. Yeah. Okay. Do me a favor and copy that down. Do me a favor and copy that down. Oh, sorry. Let me give you your homework, right? Let me give you your do that first. Let me just do the top two first. Yes. Yes. 1 second. No, it's fine. Move this up a little bit. At least you should have been able to do the first two problems. Look those over.
Oh, wait, those are the answers?
Yes. You only did one of them? I'll stress it. I'll stress it on the test if I do give you something like that. I'll say, what are both solutions? And I'll have solution number 1, solution number 2. To find the other one, plug them back into the solution. So for let's say number 4, right? You found that it was 6 ounces, right? Right. And then what did you do? You want to plug it into solution number 2, where it's 18 minus x, right? 18 minus 6 is what? Yeah, you plug it in for x.
Wait, so we have to do this?
I'm going to stress it next time. Right now, no, you're fine.
So it's just 18 minus 6. You don't put the 6 for the other x.
Right, because x is telling you you already have one solution at 6 ounces. That's solution number 1. Solution number 2 is when you plug 18 minus 6 would give you your 12 ounces. So combined, if we add those two concentrations, we're going to get a new alloy or gold metal in this case. The metallurgist needs to make it 18 ounce. So 6 and 12 is 18 ounces. Right. So I'll stress that when we get there. I'll definitely stress that when we get there. Okay. So right now, yeah, you're okay with not doing both of them. I'm not going to stress you guys out. For those that did, good. It's just extra practice. I know we covered them. Like I think we did 2 or 3 problems like that. But don't stress out. I don't want you guys to freak out. Okay. Here we go. Let's go ahead and do notes. There's only 1 page of it. Don't freak out. Properties of absolute value inequalities. This is going to be kind of key for this. Dear city. It is important that we're able to visualize and see how to solve out inequalities with absolute values. One thing that I want to stress here is we're almost identically looking at the same kind of properties that we solved out when using quadratics. That if we have a less than, oh, that's horrible. if we have a less than or equal to symbol, that we're going to be connected. This is less than. And if we have one that is greater than, we're going to have two inequalities in which are not connected. This is greater. Greater than or equal to. So we're going back to these inequalities. It shouldn't be too difficult. We should be okay. We should be all right. But we want to be able to identify these types. So it's important that we look at that, and we're going to use this a lot. What happens when we divide out by negative? Multiply by negative. What else? Flip the sign. Right. So we are going to come across those as well. So multiply or divide by negative, we flip the signs. Okay? But you still want to treat it like a parentheses. Treat the absolute values like parentheses. When we work outside the in. And when we get to the parentheses, we want to be able to rewrite it or use the equivalent form to write them out. Okay? Can I move on? Are we okay? Not yet? Give you guys more time. This is really the only one. So here we go. Let's say I'm going to go ahead and clear this. And let's just practice some of these examples. I'm just going to go into super easy different types. So let's say I give you an example like the following. Let's say I give you absolute value of a value less than 2 for our first problem. And let's say the one right next to it will be an absolute value is greater than 3. We want to be able to reference of how we're going to write this. And the first things we want to be able to see in here is once we get to the inequality, we want to see how they are written. Because it's less than or equal to symbol, we want to be able to write the equivalent form of it or convert it so we don't have the inequality. If you look at the first form, I believe, it tells us to convert it into -2 is less than x, which is less than 2. Why do we say -2 and 2? When you apply the absolute value, what is essentially the absolute value? Let's just look at this real quick. What does the absolute value actually do to, like, let's say 3? What does it actually do? Nothing. It converts it back into 3. What about the absolute value of -3? Makes it positive. So what are we really doing with the absolute value? It's converting everything to positive. Okay. That's the only thing that it's doing. So it's converting any negative values to positive. Any positive values it's already positive, so we don't have to do anything. So the reason why we reference this is because we want to be able to see how it's affecting the outside term of the inequality. Okay. In this case, our term was 2. So to convert it, it's going to use both -2 and 2 for the absolute value. So that's what the boundary is for this. Okay. Once we have our inequality here, we're done. The x is by itself, and we're pretty much done here. This is one of our solutions. If I had to graph this on a number line, let's say from 0 to -2 to 2, we graph it the same way. Is it open or closed circle? Open. Definitely open because we have the less than symbol with no line underneath it. Is it connected or not connected? Connected. In order for us to look at the connected signs, we look at our answer. In this case, it is between -2 and 2 for the x values. For something to the right, let's look at how we're going to write this one out. We're getting to the absolute value, so we got to be able to convert this one as well. just as we did before with the quadratic inequalities, we want to be able to separate these two into two different types. I believe this is rule number 3, where it's going to be two different solutions. It's going to be x is less than -3, where x is less than c in this case. And we are going to have 3 is less than x. Okay. I'm sorry? Because we're using the absolute value property to write the equivalent form of them. If you plug in 3 into here, right? 3, let's just say 3 is greater than 3. Well, it works. 3 is definitely greater than 3, right? Greater than or equal to. If we plug in -3 into here, it also works too. So we use the first value of that inequality to help us determine the boundaries of the positive and negative value of that, because we're trying to rewrite it. Okay. The more we do, the more it'll make sense. Okay. So this is actually our solution here. X is at less than -3, and 3 is less than x. Again, we can still draw these out on our number line, which I'm going to again have you guys do. 0, 1, 2, -3, 1, 2, 3. Open or close circle? Open. Okay. And looking at our solution, or looking at how we first started out the inequality, is it connected or not connected? Not connected. So it still applies the same way. Okay, we look at these parts to determine whether they are connected or not connected. So it still does the same kind of thing. We just got to be able to apply it and solve out the equations. Does that make sense? Okay, so don't freak out over this. And we're going to kind of increase as we do over time. So let's look at another set of problems. We're going to increase the difficulty of it. Let's say I give you another example. Let's see, example 2. And let's say I give you absolute value of x minus 2 is less than 3. And we'll do it the other way. X is minus 2 is greater than. No. Less than or equal to x, and we'll do greater than or equal to x. 3. So we have one version in which is less than or equal to x, and the other version which is greater than or equal to x. I keep on saying x. Well, you know what I mean. So let's look at these type of 2. So now we're adding something to this problem. We're adding an extra term. So before we get to the absolute value and solve it out, we still got to work to the absolute value. So before we kind of write the equivalence for it, we got to get rid of some values. So the one to the left, absolute value of minus 2 is less than 3. How do I get rid of that minus 2? Add it. Just as we would orders of operation. Let's go ahead and add it to our value. Let me get a nice, cool sherbet orange. I'm going to go and add 2 to this. I'm okay. You guys are like, oh my God, you're so weird. I miss sherbet. Sherbet's delicious. Gross? You're gross. Ugh. Okay. Okay. So we have we're adding to this. And now we got to be able to write the equivalency of this, right? Because we're getting to the absolute value. Okay, so this is going to go back to, I think, rule number 2, right? Where we want to be able to write the equivalence form of it, which will be the c value, which will be minus 5 is less than x, which is less than or equal to 5. And again, we could stop there because this is our solution. X is doing nothing to it, and we wrote it out. We could still draw out our inequality. So let's say the 5 to -5. Open or close circle. Closed. At 5 and -5. Connected or not connected? Connected. So we're just going to add these steps to them, and we're going to add multiple parts that we have to continue on solving. So that's how that one's going to look. Okay. Let's look at the problem to the right, where it's the same, very similar problem, and we'll kind of do this to it. Again, we could solve this out still the same way. What's my first step? Plus 2. Uh-oh. Yes, I know. Hold on. Made some boo-boos. I think I hid out from it. I don't know what I did wrong. Don't copy that down. I'm going to go back to the old one. I don't know what it just did. It just like hiccuped. Let me convert this. So let me rewrite this. What was it? X minus 2 greater than or equal to 3. So I'm going to go ahead and say add 2 to this side. So my apologies for the other one if you didn't get it down. Copy it from your neighbor. We're going to get the absolute value of x is greater than or equal to 5. Okay. And now when we're getting to the inequality, we want to be able to convert it or write the equivalency of it. So we're going to go ahead and write the equivalency, and this will be x is less than or equal to -5. And the other solution will be 5 is less than or equal to x. This is our solution here. We don't need to solve this out any further because x is already on one side. Now, again, we can draw it out. So let's go ahead and draw this out. Since I have the extra room, I'm just going to kind of draw it on the other side. On our number line, we have 0, -5. Open or close circle. Definitely want to say closed again. So we're going to say closed. Connected or not connected? Not connected. So say it's away. Kind of making sense? Okay. Let's kind of build again to that. Let's kind of build to this. So before we kind of get into more trickier problems. So now let's add something more to this. Let's say if we have something before this. Let's say we do this first. Let's say we have, so this is example number 3. Let's look at a problem that does something like this. Let's say 5x is less than 20 for one version. Yeah, we'll do less than. And just do the other one where it's 5x is greater than 20. So let's look at when we have values inside of the parentheses. This kind of changes it around a little bit. Okay. First of all, do we have anything outside the absolute value? So we don't have to add or divide out anything in first. So we're going to be able to automatically go. I have to deal with everything inside the absolute value. So from here, we got to be able to write the equivalency of it. So because it's less than or equal to, is going to go from -20 is less than 5x, which is less than +20. So we're just kind of rewriting this in terms of our equivalencies. So we got rid of the absolute value, so now we can work with it. Is x by itself on this part? So how do we get x by itself? Divide, yeah, by both sides, right? On everything. We want to divide by everything. So we're going to simplify this out and get -4 is less than x, which is less than 4. And we're done. X is by itself. Can we draw this out? Absolutely. 0 is in our middle. -4, 4. Open or close circle. Connected or not connected? Connected. Less than symbol is definitely connected. Okay. Doing the same thing with this now on the right side. We kind of separate these. Should have gave it a little bit more room. No worries. No worries. Okay, again, I don't have anything on the, I get automatically to the absolute value, so I want to be able to use this. So I got to be able to convert it. I have the greater than symbol, so that tells me I'm going to use, I believe, number 3, right? Where it's going to be 5x is less than -20 for one solution. And the other one's going to be 20 is less than x. Or 5x, sorry. 5x. Do we have to do a little bit more solving with these? Yeah. Divide both sides by 5. we're going to get x is less than -4. And dividing both sides by 5. The less than symbols are a little bit nicer because you only have to solve it once. Okay. And here's our answer. If I want to draw this one out, inequalities line. Open or close circle. Open at our values, away or connected. See what we're getting here? So we're just going to kind of keep on building and building and building. Okay. And that's all we're really dealing with. Once you get to your inequality, you want to be able to write the equivalency of it, and then the equivalency will help you graph it out when you're done. So let's look at examples. So I keep on wanting to just do examples with you guys. So we're going to skip that. We're going to skip that one too. Okay. Let's look at something where we have something both inside and outside our inequality. And I'm going to go ahead and rewrite these two because I think it's going to help you guys out. So I'm going to go x is less than 2 minus 5 is less than -2. It's okay. I didn't do anything. I'm just rewriting it to two different problems. Don't freak out. You're going to be all right. So this one has our less than symbol. For our problem to the left, I'm just rewriting it so you guys can have more examples and see the differences of what we're doing on each different type. Is that okay? I think that helps out. So one way we have the inequality, the other one we have the less than symbol and the greater than symbol. So this now deals with both a external value and an internal with our absolute value. So let's go and solve this bad boy out. I think we can do it. What's our first step? Let's work for the one to the left. So let's look to the far one. What's my first step I should probably do? Add 5. Let's work to the absolute value. So let's go adding 5 to both sides. Our 5s go away, giving me absolute value of x minus 2 is less than -2 plus 5? 3. Okay. So we're having it there. Did we get to my absolute value? Yeah. So we want to be able to do what? We've got to be able to convert it. So this is going to look at example, I believe, number 2, rule number 2. So how would I write that? Less than, which is, yes. Is it? Yes, rule number 1. I think number 2 has the less than or equal to symbol. Sorry, rule number 1. Okay. So all I did is I wrote the equivalency of that to get rid of my absolute value. Okay. What's my next step? Add 2 on all our parts. We're going to simplify this down and get, what is this, -1 less than x, which is less than 5. This is definitely part of our solution. If I graph that, let's go to my paper. Open our closed circle at 1, -1. Open our closed circle at 5. Connected or not connected? That's there. Let's look at the other type. Let's solve out the other type now. Okay, this is problem number 2 on the right. So what should I do with this? Add 5. So we're still solving out the same exact way almost. We're doing plus 5 to both sides. The only time it really changes is when we get to the inequality. So I'm going to get x minus 2 is greater than 3. Did I get to my inequality? Yeah. So now I want to be able to convert it. What rule is this? Probably, what is it, 3? 3? So let's convert it. I'm going to write it in 2 separate solutions to this. It'll give me x minus 2 is less than and -3 is one of them. And our other one's going to give us 3 is less than or equal to x minus 2. So these are a little bit more pain because we just got to work them out a little bit more, right? Doing the same exact thing essentially, but this is be more. I think just writing out this part is the hardest part, not even solving. If we add 2 to both sides, we're going to get x is less than 5. If we add 2 to both sides, we're going to get, did I do that right? I did not do that right. Should be what? -1. This one should be now 5. So this is my solution to this set, and let's do it in a different color so you guys can see it. Let's do it in purple. So our purple, this is one solution. This is our other solution. Open or close circle at -1. Open. Open and close circle at -5. Connected or not connected? Not connected. It's easy or hard? Okay, good. Let's amp it up one step further. Let's amp it up one step further. Let's see. Let's see. Copied on this one. Now, something of this one kind of changes things around. Not by much, but it changes slightly. Okay, and I'm going to show you why. Because something's going to tell me when I divide up by -8, what happens to that inequality? It flips. So this one I'm going to kind of put in quotations. It's kind of like your harder problem because you're dealing with a little bit more. Not by much. Not by much. This is a little bit hard. This is hard. But you got to be able to just follow your steps on all these. Okay? Got to be able to follow all your steps. And we'll just strictly do it on this type of problem. We're just doing greater than symbol. We're not going to do 2 different types with less than. I'm going to write it down below so I can have room. If you want to try this out and get ahead, please do so. If you want to see if you have enough gusto to get this done. So I was watching Ratatouille last night. Good movie. Yes. It changes things around, but not by lot. Okay. Here we go for our first one here. So do I have anything on the outside of my absolute value? So I don't have to worry about that. So let's go ahead and worry about converting it. So because it's a greater than or equal to symbol, we got to be able to rewrite this as a different way. The first one's going to be -8a minus 3 is less than what? -11. The other equation will be 11 is less than -8a minus 3. I don't want you to get confused on this part, so don't freak out. Okay. If I want to solve to the problem to the left side, let's say the red dot side, what should I do first? Add 3. -8a is less than, what is that? Going to be 8? -8. Then what happens when I divide out by that -8? It becomes a is going to be greater than 1. Leave it like that. This is one solution. Okay. If I had to plot that one, where would it be? Open or close circle where? Open at 1. Open at 1. And we'll deal with what direction we're going to go afterwards. Let's do the other side now. Let's do the other side. Other side is going to be adding 3 again. Just very similar to the other problem, right? Adding 3. This one's going to give us decimal, so don't freak out. -8a. Dividing both sides by -8, we are going to get -1.75. Given the decimal, you could have got -14 over 8, which is fine. But I'm giving you a decimal so we can actually plot this. This is our solution to this side. So open or close circle at -1.75. Open. Open, let's say close to 2, right? Now, because we have these 2 separate answers, are they connected or not connected? Not connected. So we could still draw them out the same exact way. Question. Yes, I divided 8 into both sides. Oh, yes, yes, absolutely. Yes, I should have changed the signs. Thank you. Look at that, I messed up. So this should have been the other way. This should have been greater than. Yes, absolutely. Change the signs. Okay. Those are our two answers. Is this hard to do? No. Yeah? Yeah, kind of, sort of? No? Okay. That's all we really want to be able to do with this. And this is as far as we're going to take it. This is kind of a trickier problem. We're going to do one more. Yes. When we convert it from this, that's when it depends. Right? If it was a less than symbol, we would have only one solution. We would have them combined it, it'd be easier done. Yeah, absolutely. Yeah, you want to be able to separate them. Here we go. Last one. Let's see if we can do a really, really tricky one. Let me see if I have a good one here. Ooh. Try that one. We'll keep it the same way. We'll make it a little bit nicer as I walk around and pass out your home. This is a type of problem that you might see it on your guys' test. So if you think this is fairly easy, good. I hope I taught it to you well. So what? I believe so. It'll be coming up very, very shortly. We just got an email for progress here. Already. I think the closing they close by next Friday, not this Friday, but the following Friday. Yeah. No, it's not too bad. This one? No, I don't think it's too complicated. Here we go. What's my first step when solving this one out? Add 10 to both sides. So we're going to add 10. I'm going to kind of do this all together. I'm going to get less than, what is that, 36? Yeah. And then to solve this out one more step, what should I do? Divide by 9. When I divide out by 9, I'm going to get a nice number of 4. And look at how beautiful that looks. Look how clean that looks. Do I have my absolute value? Should I convert it? I have to convert it now, right? So it'll be from -4 less than m minus 8, which is less than 4. And then how do I get m by itself? Adding 8 to both sides, I'm going to get what? 4. Is it okay to have both of them be positive? Yeah, absolutely. It's definitely fine. He's not dealing with any negatives. So it's going to go from 4, open or close circle. 12, open or close circle. Connected or not connected? Boom. Done. Oh, no. Choose your evens or odds. If you want more practice, I would suggest you do like 2 from each side. If you want more practice, do them all. I'll let you choose them. Evens or odds if you want to. The left-hand side seems to be a lot easier because these are the ones you just connected them. The ones on the right, I should have mixed them up. Easy day today?
So that would be the same thing for lay down. You know, to add. Okay, so it's going to be oh, actually, no, it's game. Okay, since it's game, it's too far. No. You don't have to flip it. You have to divide them. Well, they're not flipping. I'm going to it's a D minus one. Then the next one is 2. It's 3. I was like, really don't. And we're having you got this. I got one.
I did most of it. Well, I did some of it.
We literally do one. And the rest of it, you didn't finish this. It was only 6 sentences.
I know, but I was like, you know.
You got distracted.
Very defended.
I mean, do you want points for today?
But I feel like she's gonna be checking everybody else's like she's trying to finish it and then be like her too.
I'm glad she put you first.
She be hurt. And I'll be like, oh wait, I didn't even come to December.
You got
Ooh. She heard me. I saw. I need my camera.
Yeah.
No, it was bad.
What is it? What happened?
First come, first served basis, so I know that you just sort of late.
Yes. Oh my god. I didn't even have these meals. Wait, so we're gonna grab a blanket?
Yeah, if you guys want to do it, you have to put some shorts. Put some
Thank you so much.
You know the ones that get show up late.
Oh, so for them. It's a prop to show up early. I was bad for your too. Oh my god, it was crazy in there.
Here we go. Make sure you guys grab that handout too.
Tired.
Good luck, pancakes. Make sure you guys grab the handout too.
What did you say about tutoring again?
Tutoring?
Not tutoring, but you know, like help texting.
In the morning, or quickly after school. You want to get some grab some? Yeah, before you go in. Wait for my first and second period, but you guys are. Oh, they did pretty good on their test and they're well behaved. So it's kind of up to you.
All right, before they run out.
Before they run out, you want some pancakes? You know the one's gonna show up late. I'm not doing that.
Yeah, all the
If you want some pancakes, grab some pancakes before they're gone. It's a first of. Be reasonable. Be reasonable. Do me a favor, take us your homework. Why? Why? You eating healthy or what? Grab some, man. Grab some. What do you guys? Grab some. Seriously. I'm in.
I can still eat. I really don't have to.
Let me see.
Grab some if you want some before they go away. Grab some pancakes if you want them before they go away.
I did my dish on a separate sheet. I couldn't do on this.
Oh,
There's the stock.
Oh, she's turned around.
Well, we never went to each other, so I just don't come down.
Who cares?
I need water.
Wait, what?
That's a pancake before they run out.
You guys would like some pancakes before they're all gone? It's a first come, first served basis. Put them up. Grab them.